Hey everyone, in this video we're going to build a chat with a library app, and we are going to programmatically download top 100 most popular philosophy books from Gutenberg public domain books. This will include such masterpieces as Picture of Dorian Gray, A Speak Zarathustra, and Republic by Plato, for example, Critique of Pure Reason, and of course Discourse of Method. So we're going to programmatically go through this page, even skip pages and download 100 books. And when we do that, it's going to look like this. We will have downloaded the text versions of the first 100 books, and then we will process those books to remove the intros, because each book then has this intro by the project Gutenberg. We're going to remove that, so getBooks.py is going to retrieve all the books. Then we're going to remove intros from the books. And we're going to chunk the books based on chunk size or overlap present. These are based on words. Then we're going to, in parallel, embed them and create a Chromadb vector store. And then we are going to be able to query these and see the results of the queries, which chunks are retrieved from which book, which chunk index, such and so. And then finally, we will actually create a chat using GPT-4o, in which we can retrieve n many chunks from all of the 100 books and return results. Code files for this project will be available at my Patreon. Link will be in the description and in the pinned comment. When we chunk the books, it's going to look like this. As you can see, it's quite long, about 23,000 lines long, because each line pretty much corresponds to a chunk. As you can see, they're very long, and there's a 25% overlap. You can adjust all of that. But let's see what this will look like when we are actually running it. So I have two files, one just a query. For example, we can type in a philosophical question, such as how to live the best life. And then it asks us how many results we would like to retrieve. Let's say 10. And this will automatically retrieve the chunks and print them along with their index number and which book it came from. As you can see, it utilizes many books. And it also writes these results to query results.json. As you can see, the book name. So you can actually go over these, maybe find a future book to read, or actually just read the passages that are related to the kind of concepts you would like to explore. Now, the really fun part is actually to actually chat with the library. So when we run this, we are going to at first ask how many results we would like to retrieve. Let's say 20. You can change this. I'm sorry, I actually was still in the querying the library. So now, how many chunks would you like to use for context? Let's just say 20. And now we can ask the same question, such as how to live the best life. Let me zoom in. And it is instructed to give a short answer and not reference any particular person. To live the best life, it should be inspired by love and guided by knowledge. The knowledge required for a good life can be discovered and disseminated through dedicated research. A good life entails a balance of intelligence, education, friends, love, sufficient income, good health. So actually, this is a lot of fun. When we actually retrieve the chunks for this, we also save them to retrieve chunks.json. So these are chunks that were retrieved for this, all the way down to 20, including aesthetics essays of Friedrich Schiller and what have you. There's like 100 of them. We can ask another question. So, how best to study and learn? This may not be such a philosophical question, but it would be interesting to get answers based on the top 100 philosophy books of all time. The best way to study and learn is to engage directly with the material through meaningful activities and personal experiences, rather than relying purely on memorization and passive reading. Encouraging activities, participation, experimentation, problem solving. Yeah, so this is pretty cool. Again, we have saved the results to retrieve chunks. See the query and see all the books that was returned. Actually, sometimes it actually has French and German books in there as well. I didn't filter them because we are going to get answers in English anyway. So this is still useful because the model is multilingual anyway. So this is a lot of fun. Like I said, the code files along with the books will be available at my Patreon. I won't be able to put the Chromadb because it's quite large, about 600 or 700 megabytes due to size limitations. But you'll be able to get all the code files plus the books. And you can find them at my Patreon. So now let's actually dive in to the code and see how we can build something like this. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. Okay, so the first file is getbooks.py. These are numbered in the order that they should be executed. The base URL is the philosophy category. So you can actually pick a different category or whatnot, but this is actually designed to work with search results. So you would have to just find your page with displaying the results and then copy that and replace the base URL here. Other than that, we're going to take in how many books to download. We are actually looking at the main execution block, and we're going to actually look at the functions that take care of it too. But we take in user input for how many books. We create a books directory if it doesn't exist. Current URL and book downloaded, we initialize to 0. Main loop is while the books downloaded is less than the number of books specified, and as long as we have a current URL, we loop over the book URL title in this function, which is returned from this function. If we reach the limit of number of books, then we break. Other than that, we download the book and get the next page, since change the current URL to it. And actually, we give it a little bit of a sleep. So we don't want to do all of this very quickly. So if you go back to the top of the script, you can see we are importing all our libraries, requests, and beautiful soup for parsing HTML. Function to sanitize and remove invalid characters from the text file, so the titles of the book, so we can actually save them with their nice titles. So that's just to sanitize that. Function to download a book, given its URL and title. It's going to take a URL and title, sanitize its title, check if the file already exists. If so, it's going to skip it. Maybe I should have run this real quick because since I've already downloaded it, it's going to skip all of them anyway. So you can see how many books, let's just say 10. But as you can see, it's just skipping. And it's just going to skip all of it because they're all downloaded. But otherwise, it would have downloaded them. When the book already exists, we just sleep for a very short time, 1/10 of a second, and we return this as true. Otherwise, we get the response using requests, and then we get the soup using beautiful soup, and then we look for A tags, find a download link for a plain version. So I do some digging into the HTML with the, with the element marker, whatever, the select an element, in the developer console, and I actually gave screenshots of these, explained that, when we're done with all the books on this page, we want to go to the next page. Otherwise, we want to grab the title and go in there. And when we go in there, for example, there is this plain text UTF. So that's what we're doing here. So that took a little bit of research, but that's what it's doing. And if there is a download link, it constructs the full download URL and then gets the book's contents and then writes it to a file with the sanitized file name. And then it sleeps anywhere between from 1 to 10 seconds after each book download. Otherwise, if you cannot find a plain text UTF, this happens sometimes with, like French or German, like non-English titles. And we just sleep between 1 and 3 seconds. And we handle any other error that may happen. We sleep between 1 to 10 seconds in between each. And here is the function to extract book links. You get the web page's content, find all book elements as a list, extract the title and URL for each book. When we get all the lists and we loop over it, hit the title element. If there's a title element, we strip it, create a book URL, and yield that book URL and title. And function to get the URL of the next page. So when we process all the books, then we're going to go and do it for the next page. Again, get a response, get the soup, look for A tags, create a link, handle errors, and that's about it. Of course, you should only do this with wherever you can actually do this. Gutenberg is kind of like open source for books, and all these books are public domain. So when you run this, you end up with something like this, 100 books, but each one of them has kind of like an intro, and it has this little text that says "Start of the project Gutenberg." Each and every one of them has this. So the next file, essentially, remove intros from books, just kind of looks for that. Say remove intro. It finds the pattern using regex. Start of the project Gutenberg ebook, because this is present, and it removes this line and every line previous to it. See, define a pattern to match everything up to and including the start of the project Gutenberg book. Remove the match pattern from the content and it returns it. Function to process a single file. These are all async functions. We are using AIO files. I'm not exactly sure why we're using this, but it works. So this is going to async function to read the file's contents, remove the intro, is the process content, and then write it the file. And this is process books, is going to take in an input folder, which is books, and an output folder, which is process books. See, as you can see, the intro has been removed in these. We create the output folder. If it doesn't exist, we create a task list for async IO. And for each file name in the input folder, as long as it's a TXT file, get the input path, output path. We create a task for each one using the process file function, and then we append it to tasks, and then call each one of all of those tasks simultaneously with async.io.gather. When it's done, all books are processed, and we just run it with async.io.run. When you do that, then you end up with process books. Now, next one is the chunking of the books. So we are going to use math and ceiling from math for rounding up numbers, JSON for file handling. So chunk text is the function to split text into overlapping chunks. It's going to take in a chunk size. This is going to do it by words and an overlap percentage. And we're going to split the text into words, calculate the size of the overlap based on chunk size and overlap percentage, because we are specifying a percentage. It calculates it here. Calculate the step size, this thing between chunk starts. This is how we do it. Chunk size minus the overlap size chunks. We iterate through the words, creating chunks. Join words to form a chunk and add chunks to the list and return those list of chunks. Function to process all books in a folder. This is going to take an input, output file, chunk size, and overlap percentage. You can change all this. Dictionary to store chunks for the books. We iterate through all files in the input folder. As long as it's a text file, we open it, get the content, chunk it, and now store the chunks into this all chunks dictionary. And then we write it to a JSON file, such as this, as we have seen, very long JSON. So you can maybe use this for other purposes too. That's almost it. So then we give the input folder and the output folder. We determine the chunk size, percentage overlap, we process the books, and we just print that this has been completed. Next up is how to embed and create the Chromadb vector store. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses, and my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. So I'm not actually going to run this because this actually took quite a while. I also have this count token. It uses tick token to count all the tokens in each book and all books. And actually we can take a look at it token and word counts. See, a little philosophy of life has 9,100 tokens and 6,700 words. This is like the token and word counts for each. Here's a more concise description. The bottom line was that there was 12,752,000 roughly tokens. And I actually calculated this. This cost me about $2. We're using text large 3, I believe, from OpenAI. So this wasn't bad, except it just took a while. I'm not sure why it took so long. I'm not sure if I made a mistake with the async implementation or if the API was bogging down. But this took about 2 hours, but it's not expensive. This is literally 100 books and 17 million tokens. We get the embeddings using Chromadb from OpenAI using text large 3, and then create a vector store from that. So we are doing all of our imports in this number 4 embed chromadb.py. We are going to use the embedding functions because we want to specify an embedding function, and we want to use, at least I wanted to use OpenAI text large. Term color for color console output, function to load chunks books from JSON file, open and read JSON file asynchronously, again using AIO files, and return it. Function to embed a single chunk into a collection. So this is going to actually use semaphore because we can limit the amount of synchronous connections. I want to use semaphore more, because async can do hundreds of thousands of calls at the same time. So if we say async with semaphore, and as you can see, we are actually defining the async IO semaphore as to do only 30,000 connections. You really should consider semaphore because sometimes if you make a mistake in your code, you could be making tens of thousands of hundreds of thousands of calls, as I've done one time, and you can get charged quite a lot for that. But anyway, that being said, we are using semaphore, and we are just using ChromaDB's collection add, and it's going to add the chunk. This is going to actually know how to convert it to embeddings and everything. ChromaDB just makes it so convenient. But we are going to be defining the embedding function, as you'll see down here. But the next function is to process all chunks from the book. It's going to get the chunk books collection and max books. If you want to test this with a few more books, you can set a max book parameter. We create a semaphore to limit the concurrent operations to 30,000 tasks, and then we iterate over each book. I book title in chunks and enumerate chunk books.items. Literally this JSON object right here. And then if max books is reached, then we break, so this will only work on the books, as many max books as you have specified. Other than that, we enumerate over the chunks and create an async IO create task, calling the embed function with the collection book title, J chunk, and semaphore, all of which we have extracted right in this moment. We append all those tasks. Here we get the length of tasks, and now we just print it as information and wait for all tasks to complete by calling async.io.gather. And the main function to orchestrate the embedding process is to load the chunks first, then initialize ChromaDB with persistence to add this directory right here. So we can load it and then create an OpenAI embedding function. That's why we imported the embedding function so that we can input our API key and then specify the model name, text embedding 3 large. You can use anything you like. Another kind of interesting point here is that when you're getting or creating a collection, you only have to do this, I believe, when you're creating a collection. You can specify the distance calculation, like cosine similarity. I wanted to use cosine similarity, but I think they use something like TF or something by default. I don't know which one is best. I just always heard cosine is a good way to go. So this just was this is in documentation. And we are passing the embedding function and naming this as the book collection, embedding function being text embedding. Then we pretty much process all embed chunks with the process chunks function, calculate and print the total number of embedded chunks, which is in a less comprehension way. Sum it up and print it, and I run it with asyncio.run main. So this is, and then once it is done, you have your vector store which you can use. And in the fifth and sixth, we actually connect to this persistent ChromaDB, which you only have to create once. And this one only queries it. And 6.1 creates a chat with it. So let's review the code for those now. So there's going to be some similarities between 5 and 6 because we're going to connect to the Chromadb vector store the same way. Here we are getting an embedding function again because we still have to embed the query, right? And term color. Function to query the collection. Query collection is going to get a query and it's going to get some end results here, default 5, but actually we are specifying. I need it down more later in the code. We say the client is going to be Chroma persistent client. This is the path to it right here, Chroma underscore DB. Again, we're defining an embedding function exactly as before. Get the collection with cosine similarity. Actually, this doesn't take that meta argument that we looked at for cosine because it's already built into it. So that's it. You just get collection, book collection, and embedding function. That's for queries. Query the collection is just so easy. It's just you say collection.query, query texts and results, and this will return the results. Function to save the query results to JSON. We create a JSON object for query and results list, iterate through the results, and then save them as like result number, book title, because we are adding the metadata to the ChromaDB, chunk index, and then the content. Yeah, right here, I just went back to the fourth file. I don't know if I accidentally skipped over it, but collection.add, we add the documents, it's one by one, right? And but also the metadata as book title and chunk index. You can add any metadata you like, and plus IDs. We just add the book title plus the chunk number as the ID. Just want to clarify that. So we do have these metadata, which we are creating into the JSON object, and now we just save it. Right? This is what creates the query results, as you see right here. Walter's Philosophical Dictionary, chunk number 133 is this one, for example, related to the query. This is an accident, of course, but you can find the query later. I accidentally ran this while the query library script was running. Main function to run the query. Welcome to book query system. You can ask questions about the books in the collection. Within a while loop, it asks, well, enter your query, check if user wants to quit, and then asks how many results you would like. Then we query it, and then we print the results along with the book name, chunk index, and content, but we also save the results each time into this query JSON. So the next one is going to be very similar, right? We are query collection. Again, we are importing the embedding function from chromadb.utils. We define the client, given it the path, and then define our embedding function along with our API key. It's being detected from environment variables, system environment variables. Get the collection from the database. Again, the same as before. This is same. Save chunks to JSON is pretty much same. Query and chunks. We again iterate through and import, put them in, such as like this, and I save them. So function to generate response, which is going to take in a client, query, and context. So here's the system message. Very helpful assistant. Answer the query based on the provided context in 100 words or less. Feel free to change this. Unless user asks for more detail, do not refer to any author, but just combine the best pieces of the provided content to answer the query. Only answer based on the provided context. Now, as a user message, you pass the context plus the query. You can definitely improve this. Then we call chat.completions to GPT-4o. You can also use mini, right? Cheaper. We are doing streaming, so we make sure chunk.choice's first element delta.content exists, and we just print it. That's all we care about using the term color library. So here we say welcome to the book query system in the main function, initialize the OpenAI client. Then how many chunks? We only ask this one time. We don't keep asking it in the chat loop. So this is where you enter 5, 10, 20, 50, however many chunks you like. It's just going to grow your context and it's just going to be more tokens. Just remember that. 500 words each though. Enter your query. We query the collection, save chunks to file, and prepare the context for AI response. We join the book metadata title and a chunk index, not that we need it exactly, and then the content for all the docs and metadata in the results that was returned. Then generate and print the AI response. AI is generating response, which is just print this generating response based on context. And when we call this, it'll automatically print to the terminal because we are doing streaming. And then thank you for you when you quit. This says thank you for using and just call the main function. And this is it. So I really enjoyed this actually. I actually enjoy using this script, and hopefully you'll find this useful. So we are able to chat with an entire library, and we are not. There's no limit to how many books you can put in there, or the kind of books, right? Could be textbooks and all of that as well. Just make sure to use the stuff that is that you purchased or that is available through public domain. And like I said, the code files for this, along with the books, will be available at my Patreon. Link will be in the description. By becoming a patron, actually, you'll not only have access to this project, but 250 other projects as well. I also do weekly Ask Me Anything meetings with my Architect Plus patrons. So we get to have some interesting conversations. So that's a benefit as well. I also have my 1000x masterclass, in which I actually create projects like this from scratch. It's kind of like a code along or like live coding using Cursor. So I think it's greatly helpful if you want to check those out. And if you want to talk to me one on one, I do offer consulting and one on one video meetings. You can find those at the higher tiers of my Patreon as well. If you just want to get in touch with me or if you needed help with your projects, I have 1 hour per month and 3 hours per month tiers available. Also, I'm much more active on X right now. I handle this at hive_echo. So if you wanted to check it out, actually, it's just today, 2024 Stack Overflow Developer Survey came out. So I was posting some stuff about that. So if you like that kind of stuff, do follow me. I do post shorter videos there too. Other than that, thank you for watching, and don't forget to subscribe if you would like to be notified of future videos, and feel free to like this video if you found it useful. I'll see you in the next video. Thank you. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.